let us talk about different options we can use in our scans to bypass firewall. Firewall is something unpredictable. You don't really know its rules in order to know exactly what type of scan you need to perform in order to bypass it. Some of the firewalls could use MAC address filtering in order to allow certain devices to connect to a specific port, or in order to block a certain devices. Some firewalls could block different types of packets. Some firewalls could block only some ports and not all of them, and we can't really know what the exact rule is. What I'm going to do is I will give you a few different options as to what you can try in order to bypass firewall. First of all, how can we know if some of the ports on target machine are behind a firewall? We already mentioned this in the previous video. Nmap will tell us that those ports are filtered. By now, we should already know what filtered port is. But let us define it once again. Filtered port is when Nmap can't figure out whether a certain port is open or closed, and that is due to it dropping packets possibly because that port is behind a firewall. Therefore, we don't get any responses back from that port, and Nmap flags it as filtered. Let me show you this on a Windows machine. Right here, I have Windows 7 virtual machine, and this virtual machine, if I go to the control panel, and then System and Security, and Windows Firewall, this machine has firewall turned on. If I try to scan it using SynScan, which we covered in the previous section, so let's do it right here. Remember, it requires sudo privileges, so sudo nmap-ss, and then the IP address. I will use the IP address of my Windows 7 virtual machine. And if I press here enter, type in the password, in just a few seconds the scan will finish. And we're going to compare this result when the firewall is turned on with the result once we turn off the firewall. So let's wait for this to end. And here it is. It doesn't have any port open. Matter of fact, it will tell me all 1000 scanned ports on this PC are filtered. Now, this doesn't mean that all could be closed or all could be opened. This just means that they are behind the firewall, and any packets we send get dropped by that firewall. So our target could have a few ports open and other closed, but we don't really know that. Let me show you the response of the same scan once we have that target turn off their firewall. So let's go to Windows machine, and I will click on this turn Windows firewall on or off. And in both of these settings, I will select turn off Windows firewall. Click on OK. And now, once the firewall is turned off, let us perform the same scan that we did right here. So we'll just use upper arrow, run the same command, and here it is. We can see that some ports are indeed open. This firewall right here doesn't have any special rules since it is made to block all traffics, so techniques that I'm about to show you in these few videos will not work on regular machines that just turn on their firewall and that don't accept any type of connection. However, once firewall rules are applied, and they usually are applied in some servers or machines that need remote access or that need to communicate with other machines, then we can test these options and see whether those rules have any vulnerability that we can bypass. I will turn the firewall back on, right here. I will close this, and let's start with our first option. We're going to use an option -f. So if I clear the screen and type the command sudo nmap-f and then the IP address, this -f option causes the requested scan to use tiny fragmented IP packets. Now you might be wondering, why would we do that? Well, the idea behind this is to split TCP header over several packets to make it harder for packet filters or intrusion detection systems to detect what you're doing. If we specify the option once just by adding one -f, the Nmap will split the packets into 8 bytes or less. So if your packet had a 24 bytes TCP header, this would be split into 3 different packets of 8 bytes. Now, you can also specify the option twice with -f and then once again -f. and this will split the packets into 16 bytes per fragment. But be careful once running this option on an actual target, as some programs have trouble handling these tiny packets. If you want to increase fragment size even more, you can use the option --MTU, and after it the fragment size. Just remember that offset you specify must be a multiple of 8. This fragmentation won't always work. If I run this scan, this option will not work most of the time actually. It only works if a network that you're scanning can afford the hit that this will cause. Therefore, they just leave it disabled. Some networks also can't enable this because fragments may take different routes into their networks. Nonetheless, it is good to mention this option, as it might come in handy one day. Another option we can use, which is more focused on hiding your IP address than bypassing security, and that option is creating decoys using -D. So if I specify dash and then capital D, creating this decoy scan makes it appear to the target as it has been scanned not only by you, but also by the decoys that you specify. So their intrusion detection system might report multiple IP addresses that scan them, including yours. But they will not be able to determine which one is real. So you successfully hid your IP address from them. There are two ways that we can do this. And just to show you how this works, what I'm going to do is I will open a software called Wireshark on my Windows 10 machine. And with this software, we will be able to see which IP addresses are communicating with my Windows 10 machine. Now you don't need to have Wireshark for now, just pay attention to the scans that we perform and results that we get in Wireshark. Right here, I will select Ethernet, since that is what I'm currently using, and we should already see some packets coming in. But these packets right here have nothing to do with our scan. So if I go back to my Cal Linux, and I run the command sudo nmap-d, and to specify how many random IP addresses we want to use to scan the target, we can specify -d and then rnd, 2 dots, and then the number of IP addresses we want to use. So in this case, I will use 5 random IP addresses. If I press enter right here and go to my Wireshark, it doesn't seem to be flooding anything. Are we successfully scanning? Oh, that's right, we are scanning Windows 7 machine, my bad, so we need to be scanning our Windows 10 machine, so let me check the IP address of my Windows 10. ipconfig 192.168.1.7, and right here I will just change from 16 to 17. And let's go back to Wireshark once again. It doesn't seem to show for some reason. Let us try adding this command, and we will use the synscan to perform this. Press enter. And the reason this might not work is because sometimes Wireshark will have a problem capturing the packets that we send from a virtual machine. And that is mostly because we're scanning our host machine from the virtual machine. So what I'm going to do is I'm going to go to my laptop and run the same command. Give me just a second, and I'm running the same command that we ran right here. I just ran it, and if I go back here we can see now the output. We can see that our Windows 10 machine is getting flooded with random IP addresses. If I stop it, I can see different IP addresses right here. So we got 193.245.213.77. We also got the other IP addresses, but I will also see my laptop's IP address, and it kind of sticks out. Since this RND option that we used creates random IP addresses, all of those random IP addresses will be truly random, while the only IP address that will stick out will be this 192.168.1.10, and that is a local IP. So this will most likely not work. They will recognize it as the true IP. So how can we change this and make it seem like the scan is coming from 5 local IP addresses that belong to my home network? Instead of running the command like this, what we can do is we can run the command like this, so sudo nmap and then -d, And after -d, we specify 5 different IP addresses, including ours. So we'll specify 192.168.1.2. Let's also use 192.168.1.5, for example. Let's use 192.168.1.6. Let's use 192.168.1.15. And let's at the end use my IP address. And to specify the Cal Linux IP address, we can simply type me. What this command will do is it will use these random IP addresses to scan the target, including our true IP address. So all we need to specify is the IP address of my Windows 10 machine. And if I run this, go back to Wireshark. Yeah, of course, once again, I must run this from the actual laptop in order for this to work. So what I'm going to do is I'm going to run the same command in just a second. And I'm running it right now. If I go to my Wireshark, here we can see now it is getting flooded with local IP addresses. We can see 192.168.1.2, .1.5, .1.15, and .1.10. And they will never really realize that this one is the correct IP address, since they're getting flooded with a lot of them. And you can change this number, you can use more IP addresses if you want, or less. But the point of this is that in case you're scanning a target that is inside the same network as you, use local IP addresses. And in case you're scanning the target that is outside your network, you can use this option right here, which will generate random IP addresses. And the security will have a hard time figuring out which one is the correct one. Cool, right? Now, don't worry, since this didn't work on my Windows 10 machine. The only reason it didn't work is because my Cal Linux machine uses the same network interface as my Windows 10 host machine. If you were to scan any other target except your host machine, this would work in every case. So for now, we looked at these two options, and in the next video, I will just quickly mention a few more options used to evade security, and then we will proceed to vulnerability analysis, which is the last step before we start gaining access to our target.